Okay, so quickly summarizing, we basically figured out this part here for Danica's chart. That's pretty straightforward. And then we talked about the fact that they want us to identify what does this mean. As I look at now here's where you just have to get good at making connections. You can't say this is like another problem. You have to look at the problem and say, hey, I'm a logical person. What's a logical connection that I can make? I'll pay you again extra credit. Do we want to pay attention to the red definition? Or do we want to pay attention to the green definition? The question says, what is true about this? We don't want to pay attention to both of them. We only want to pay attention to one. Which one and why? Like the problem's telling you. It's telling you which one you should pay attention to and why. You have to see that for yourself. Stephen?
The red.
Tell me why.
Because we don't have any of the other coordinates for f prime, and we have the two other coordinates for f, so then we can find the slope.
Well said. For the video, what Stephen said was, hey, I'm going to pay attention to the red definition because I'm looking at a table of f. So, hey, maybe I can find something out about the tangent slope of f because I'm looking at a table of f. Somebody knew it before he said it. 2 points, 3 for Dave. Sorry, Stephen. Question. Okay. Now, the other thing that happens in AP problems all the time is you just have to look at the clues you have and find flashcard memories that tell you, oh, that's right, I can use this fact somehow. But if you haven't done the flashcards, you don't find the memory. You're like just stuck. So I know I'm supposed to be thinking about the tangent slope of f at x equal 3. Sorry, lots of advice. Don't do these things in your head. Like when you try to process all this in your head, it's too much. You can't straighten it out. Get it down on paper. I would not have tried this. I myself, 15 years of calculus experience, I would not have tried to solve the problem without writing down Danica's chart. I won't do it. I'll get mixed up. So I'd write down Danica's chart. I don't write this down because I've done this flashcard enough I can just remember that. Then I would notice a connection. I would say, wait a minute, f is concave up. That means the tangent slopes of f must have, they must increase slope by slope, which means the secant slopes of f also increase slope by slope. You are going to want a flashcard that says that. I'm not sure exactly what you should put on the card, so let me explain it again. I look at my clues and I know I am looking to figure out something about the tangent slope of f at x equal 3. But you can't actually find a tangent slope from a table. You can find secant slopes. So the connection is if f prime is always increasing, therefore f is concave up, that means when I look at the graph of f, let's see, f is increasing and f is concave up. So f will have an appearance something like this. Concave up means as I check slopes on f, like if I go from this slope to this slope to this slope, checking different slopes on f, the values of the slopes must increase. The red slope is more positive than the green slope. The purple slope is more positive than the red slope. That's true because f is concave up. Okay? That's always true when f is concave up. You need some sort of flashcard to remind you of that fact so that when you look at your Danica's chart and you see the word concave up right here and you say, wait a minute, I'm supposed to be finding out something about the tangent slope of f. Okay, I remember now. As I go from tangent to tangent, I have to observe an increasing sequence of slopes. And you need me to talk more about that. If that's not clicking, you just keep pressing me. I'll keep finding new ways to say it. Okay? But if the tangent slopes are increasing like I just showed you, so are secant slopes. So if I go from point to point and find slopes, something like this, there's a pink slope, here's an orange slope. These are secant slopes. Same pattern. The orange slope is definitely more positive than the pink. The slopes are increasing. I put that all together. I'm supposed to figure out what's happening right here. This green slope. Okay, I'm hoping your eye can see. The green slope is more positive than the pink. This green right here is more positive than the pink. But the orange is more positive than the green. That's the concept they're testing you on. They're testing to see if you understand what is meant when we say F is concave up. Does anyone want me to talk more about that? The best would be is if we talk back and forth a little bit. So are you okay? Like, are you totally, if you're not comfortable, just say you're not. Are you totally comfortable that they told me in the problem that F is concave up?
Yeah, I got that, and then like the slope will be constantly like increasing but I don't know how that relates to like actually using the wall.
Gotcha. So Ella said she's good with the idea that because F is concave up, as I check this slope compared to this slope,
Yeah,
I must
that was
observe
steeper slope.
steeper and steeper. Be careful about steeper, that can lead to the wrong answer. The key thing is this pink slope is positive. This next tangent green slope right here is more positive in value. And then the orange slope is even more positive in value. Are you comfortable with that?
Yeah.
You good with that?
Yes.
You can see that in the picture, right? Awesome. They want you to figure out something about this. F prime of 3. Well, this point right here that I'm focused on, that's an x coordinate of 3 in my brain, because that's the point I want to pay attention to on the graph of F. And I want to pay attention to the tangent slope right here, this green slope of F at 3,33. Are you comfortable there? I do not know the value of this slope, but I know something about it compared to other slopes, because I can go to this point now, 4,40. Giving Ella a ticket. She's doing exactly what you need to do. It's like if it doesn't click, you just talk about it some more. Points for the whole room. Raise your hand if you can tell me the secant slope of the orange line. What is this orange secant slope? Hands up. What's the orange secant slope? Let's go, Sammy.
7.
So let's see. From here to here, Sammy, the change in y is how much?
7.
Yeah, sorry, that was a dumb question. 7. Sammy's like, 7. Change in x, Sammy, is? 1. Sorry about that. How many knew it? 2.5 for Sammy. So. Okay. Oh, please.
How would you know to not go from point 4, 3, or 33 up to that one?
I actually need both of them. Because, again, what they're testing you on, Abby, is, so Abby's question was, why not go from here, right, Abby?
Yeah.
They're testing you on what I was explaining to Ella. They want you to pay attention to 3 slopes. the tangent, like I know they want me to pay attention to this green tangent slope because that's what this symbol represents, is the value of that slope. They also want me to pay attention to the preceding, like the left word secant and the right word secant, because they want to see if I understand that when I look at those three slopes, I must see a sequence that increases. Does that answer your question? So it really didn't matter that I went here first. I could have gone here first. I just have to do both.
Okay.
Is that better?
Yes.
5 points. Please, Ellen.
Sorry, what's the difference between, like, I guess I don't get secant slopes and like how they exist and work and like do everything.
No worries.
Like,
So
I don't know what they are compared to a normal slope. I don't.
You're okay. So Ella's asking the question, like, give a little more clarification as to what we mean by secant slope. Fair. Previous to this class, you had classes where they would give you a line and they'd say, find the slope. And you simply computed the change in y divided by the change in x. Correct? Perfect. All we're doing in this class is we're saying, oh, if we have a curve, let's go like this. Okay, everybody focus hard. I'm going to show you something that messes people up. You don't want this to mess you up on the retake. Say it out loud, please. Concave up or concave down? Concave up. A secant slope is simply a slope from one point to another along this curve. Like this. That's a secant slope. It is calculated exactly the same way we find this slope. Just the change in x, change in y divided by change in x. Does that answer your question? Again, what they're testing you on is, look at this curve and identify three slopes. Orange, red, and green. Raise your hand, please. I'll pay you. Trick question. Raise your hand if you know the answer to the trick question. Which of those three slopes is most positive? Hands up. If you understand why it's a trick, you'll get it right. Which of those three slopes is most positive? Which of those three slopes is most positive? Caleb? None of them. They all have a negative slope. Everybody knew it? 2 points, 3 for Caleb. Here's where I was saying, you got to be careful with the word steep. It causes problems. Look at this. This curve is concave up. Therefore, as I go from slope to slope to slope, I must observe slope values that increase. This orange slope is negative. I don't know what slope that is, so I'm just going to call it negative 10. The red slope is less negative. So maybe it's negative 6. The green slope is even less negative, maybe negative 2. I don't really know, I'm just making up some numbers. That's what is meant by concave up. As I went from slope value to slope value, I observe values that increase. Question? Claire, yes? No. Oh, shoot. Ellie. You had the glasses on. I couldn't recognize you. The mask. Like I'm saying, she walked in the room like, one of Mr. Rucky's students came. Sorry, Ellie. The glasses threw me off. So, anyway, that's what's meant by concave up. Questions? Ella, I don't know if I helped with the whole secant thing.
No, yeah, you got it. It's just the slope of curve.
Yes, perfect. From point to point. Versus tangent slope on a curve is a slope at a point. Just one point. So tangent slope is the slope right at that spot. Secant slope is the slope along a curve from point to point. Anybody else? Okay, back to here. quickly, just better that you think with me. Hands up, what's this secant slope? That wasn't really hands up, but whatever. 5, okay. Questions? So now we know what this is. It's got to be between. It's got to be between. That's what they're testing you on. Now here's the bad news, okay? They'll find a new way to test you on that. Like they won't change the concept, they just change how they find out if you know the concept. That's what you have to focus on. Does anyone want me to talk? There'll be 3 questions on the retake that will test you on this concept.
So what's the
So, you're okay that we have these 3 slopes, right? Pink, green, orange. So we've got pink right here, green, this pointer is no good. Green, and then orange. Because the curve is concave up, I must have a sequence of slope values that increase. So if the pink slope, right here, this pink slope, that's not what I wanted. If this pink slope is 5, the green slope must be more than 5. Does that make
So it
sense?
has to be like in between the
Yeah, there we go. The orange slope is 7. The symbol F prime of 3 means the slope of the green. So that's got to be in between somehow. The only number that's in between is 6. It says could be. It doesn't say it is. It just could be. Good. Anybody else? Cool. Stop that. One more comment, then we'll go to Venus' question. Hey, very serious. There will be 3 questions. Just sit where you're like, oh, I'm apparently COVID positive because no one's sitting here. I actually am not. That was a bad joke to put on the video. Oh, I'm sorry. Not true, not true, not true. Anyway, they will have 3 questions on the retake that will test you on this idea. Like, what does it mean to have F be concave up? That's what it means. Okay? Follow-up questions. Mia, which one you want? 6.